Hi guys, welcome to today's tutorial. Today we'll be treating trigonometry. After this class, there will be practical questions to be answered. So ensure you stick to this channel to get the questions uploaded. And if you haven't subscribed, ensure to subscribe. Now, looking at our trigonometry, let's start with definition of trigonometry. What is trigonometry? Trigonometry is a branch of mathematics that deals with the relationship between angles and the sides of a triangle, most especially your right-angled triangles. Yes, we know we have different types of triangles. We have the scaling triangle, we have the equilateral triangles, we have the isosceles triangles. But for trigonometry, it basically majorly focuses on the right-angled triangle. Now, what are right-angled triangles? Right-angled triangles are triangles which have a particular or a specific degree at 90 degrees. So once we have a degree at 90 degrees, then we know it's a right-angled triangle. So if we have a triangle in this form, and this is in 90 degrees, then we'll know it's a right-angled triangle. Now, a naming of our right-angled triangle gives rise to our basic trigonometrical ratios. Now, we have two sides. We have, let's call this side X and side Y, and we have side Z. So for side X, if we have another known angle together with our 90 degrees, all right, the known angle facing, which is our side X, will form our opposite. So we can say opposite is the side of your right angle triangle facing a known angle. All right, opposite is the side of a known angle facing the known angle. Right side of a right triangle facing your known angle, while your adjacent is the side of the right angle bearing your 90 degrees and the known angle. Your adjacent is the side of your 90 degree, is the side of your right triangle bearing your 90 degrees and your adjacent. Now, so this would be our adjacent, and your hypotenuse would be the side facing your 90 degrees. So your hypotenuse would be the side facing your 90 degrees, and is often referred to as the longest side of the right-angled triangle. Now, we can find our trigonometrical ratios from a short formula known as SOHCAHTOA. Now, this simply means for your sine theta, you have it as opposite over hypotenuse. Your cos theta, you have it as adjacent over hypotenuse. And your tan theta, you have it as opposite over adjacent. So bearing in mind the meaning of our SOHCAHTOA, we could always find any given angle in our right-angled triangle. Now, looking at our basic trigonometrical ratios, like we've earlier said, sine theta is opposite over our hypotenuse, cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. Now, from those basic trigonometrical ratios, we could get the inverse of those ratios, which is cosec, our secant, and our cot or cotangent. Now, we have our cosec as 1 over sine theta. All right. Now, if we have it as 1 over sine theta is opposite over hypotenuse. This becomes 1 over opposite over hypotenuse. So if we do the inverse of this becomes hypotenuse over opposite. All right. Now, so if we have a sec theta, we have it as 1 over cos theta, which is 1 over adjacent over hypotenuse, which will give us our hypotenuse over adjacent. And we have our cot theta, which is 1 over tan theta. Okay, and 1 over tan theta is opposite over adjacent, which will give us adjacent over opposite as our cot theta. Now, it is important to also always remember each and every of these and how they are derived. Now, talking about our trigonometrical standard angles, now we have, how do we generate? We have our special angles, what we call special angles. All right, we have angle 30, 45, 60, and angle 90. Now, for each and every of this angle, we can derive them from this, a right angle triangle and an equilateral triangle. All right, for a rectangle triangle, we have here as 90 degrees, 45, and 45. So let's assume this is, since they have same units, 1 unit. Now for an equilateral triangle, this would be 2 units, 1, 1, making 2 units. We know an equilateral triangle is a triangle whose sides are all equal and angles are all equal. So that means this will be angle 60, angle 60. Now this will be angle 30 and 30, making 60 degrees. All right, now with this, we can define our hypotenuse. Now, in order to find the hypotenuse from this angle, from our rectangle triangle, we will use what we call our Pythagoras theorem. Now, using our Pythagoras theorem, we know that our hypotenuse squared equals opposite squared plus adjacent squared. Now, this is a hypotenuse as x. This would be x squared equals 1 squared plus 1 squared. So our x squared equals 2. Okay, so x equals square root of 2. So here we are having our x, our hypotenuse, as square root of 2. Now from here, let's work on angle 45 and angle 90. Now if we say sine 45 will be what? Since we know that, so remember our so, ka, and toa. Okay? Sine 45 will be opposite over hypotenuse. So here, let's have this as our opposite and adjacent. Alright? So our opposite here is 1. Opposite over hypotenuse. We have it as 1. And the hypotenuse will be root 2. Okay, so our sine 45 will be 1 over root 2, but since this is a short form, we can convert it to be 1 times root 2 over root 2 times root 2, which will give us root 2 over 2. All right, now this gives us our answer for sine 45. All right, now looking at cos 45, we have it as adjacent over hypotenuse. And the adjacent is also 1. Hypotenuse is root 2. So applying same formula here, we have root 2 over 2 as our cos 45. Now, looking at tan 45, which is opposite over adjacent, we have it as opposite is 1, adjacent is 1, which is 1. So our tan 45 would give us 1. So that's how we arrive at all these angles for sine 45. Now, looking at sine 90, our sine 90 would give us opposite over hypotenuse. Now, our opposite is 1, and okay, now this is our known angle. So here, our sine 90 will give us 1. All right, and our adjacent will be 0. Our cos 90 will be 0, and tan 90 will be undefined. All right, now let's look at this other triangle on my equilateral triangle. We have this triangle in this form when divided into 2 as 60 degrees and 30 degrees. Okay, so this is 2, this is 1. So we have to find this. This is our hypotenuse, bearing in mind that this is at 90 degrees. So this is our adjacent. All right, so we have to find the opposite, considering angle 60. When considering angle 60, this x is our opposite. But when considering angle 30, 1 is our opposite. So considering angle 60, let's find our opposite. We know that our Pythagorean rule, hypotenuse squared equals opposite squared plus adjacent squared. So our hypotenuse here is 2 squared plus equals 2 squared equals 1 squared plus x squared. Okay, now this becomes 2 squared is 4 equals 1 plus x squared. So x squared equals 4 minus 1. X squared equals 3. So therefore, x equals root 3. So that means the value of x here will be root 3. All right, so let's find angle 30. Considering our angle 30 here, considering angle 30, all right, this will be our opposite, this will be our adjacent, and this will be our hypotenuse. All right. Now, so we have sine 30 equals opposite over hypotenuse, which gives us our opposite is 1 all over hypotenuse, which is 2. Okay, so our sine 30 gives us 1 over 2. Then we have cos 30, which will give us adjacent over hypotenuse, and adjacent is root 3 all over 2. All right, and sine 30 equals, tan 30 equals opposite over adjacent. Opposite is 1 and the adjacent is root 3. So when we rationalize, this becomes root 3 over 3 as our adjacent, as our tan 30. Okay, so next, considering angle 60, all right, if we consider angle 60, our root 3 becomes our opposite, while 1 becomes our adjacent. All right, so here we have it as sine 60 would give us opposite over adjacent, which is opposite is root 3. Sorry, opposite over hypotenuse, sine. Opposite is root 3 and the hypotenuse is 2. That gives us root 3 over 2. And we have cos 60, which is adjacent over hypotenuse, which will give us 1 over 2. And tan 60, which is opposite over adjacent, would give us root 3 over 1, which is root 3. Okay, so with this, we've been able to explain how our trigonometrical special angles are gotten from our trigonometrical ratios from our triangles. Now, the next thing we'll be considering is how these trigonometrical ratios are applied in quadrants. Now, we call it the cast rule. Now, having our cycle is divided into 4 parts known as quadrants. Okay, we have our first quadrant, second quadrant, third, and fourth quadrant. Now, in each of these quadrants, the basic trigonometrical ratios are applied in different ways. Now, in the first quadrant, all, that is your sine, cosine, and tan, are all positive. And this angle are always acute. Now, when we talk about acute angles are angles that are between 0 to 90 degrees. All right, now, acute angles of your trigonometrical ratios are always positive, once they are in the first quadrant. Now, in the second quadrant, only sine is positive. Okay, that means in your second quadrant, you have sine to be positive, cosine is negative, and tan is negative. All right, now, in the third quadrant, only tan is positive. Okay, you have your tan to be positive, sine is negative, and cosine is negative. And in the fourth quadrant, only cosine is positive. So cosine is positive, sine is negative, and tan is negative in your fourth quadrant. And these angles, and each of these quadrants have their range of angles. So for the first quadrant, we have it ranging from 0 to 90 degrees. Okay? Now, in the second quadrant, we have it ranging from 190 to 180 degrees. Now, in the third quadrant, we have it ranging from 180 degrees to 270 degrees. And in the fourth quadrant, we have its range from 270 to 360 degrees. All right, now how do we find the acute of these angles in each of these quadrants? Now, normally in your first quadrant, it's always acute. Okay, so in your first quadrant is always acute. For the second quadrant, for your second quadrant, for you to find the acute of this angle, here you will be doing your 180 minus theta. Okay, 180 minus theta will give you your acute angle in your second quadrant. In the third quadrant, for you to find your acute angle, you will do theta minus 180 to find your acute angle. And in the fourth quadrant, for you to find your acute angle, you will be doing 360 minus theta to find your acute angle. So all this will give you the acute angle for each quadrant. Okay, so these formulas will give you the acute angle for each quadrant. In your first quadrant, they are always acute because they are less than 90 degrees. Now, looking at our trigonometrical identities, some important identities to always remember include your sine squared theta plus cos squared theta equals 1. Now, you need to always remember that your sine squared theta plus cos squared theta equals 1. And also that your sec squared theta equals 1 plus tan squared theta. Okay, sec squared theta equals 1 plus sine tan squared theta. And okay, you have your cosec squared theta equals 1 plus cot squared theta. Okay, your cosec squared theta equals 1 plus cot squared theta. And from in your right angle triangle, when you have alpha and angle beta, okay, now It is also important to always remember that your alpha, angle alpha, is complementary to angle beta. Now, what do we mean by that? We are simply trying to say that alpha plus beta would give you 90 degrees. So when you have your alpha, sine alpha, okay, this is considering alpha, this is opposite, and this will be adjacent, okay. Now, considering alpha, sine alpha, which is opposite over adjacent, okay, would give us same thing as cos beta. And considering cos beta, here will be our adjacent. Considering beta, here will be our adjacent, and here will be our opposite. So considering our cos beta, we'll have it as adjacent, which is opposite for sine alpha over adjacent. Okay, so considering this, we have our opposite here, which is our adjacent for cos beta, and we have it as hypotenuse here. All right, so we can see that if we have sine alpha, we can get our beta to be 90 minus alpha, okay, to give us beta. So bearing that in mind, that our 90 minus alpha will give us beta, so our beta will be 90 minus alpha, and our alpha will be 90 minus beta. So whichever way. So now, looking at sine 90 minus theta will give us cos theta. Okay? Why? Because our theta, let's say this is theta. If we have this as theta, that means our 90 minus theta, our 90 minus theta will be the cos of sine 90 minus theta. Okay? Then we have cos 90 minus theta will give us sine theta. Okay? So 90 minus theta will give us our cos, while cos 90 minus theta will give us our sine. So next we'll be looking at is the sum and difference, angle sum and difference of our trigonometrical identities. Now, if we have sine A plus B, okay, it will be sine A cos B plus cos A sine B. Now, if we have sine A minus B, it will be sine A cos B minus cos A sine B. So if we have cos A plus B, we have it as cos A cos B minus sine A sine B. And if we have cos A minus B, we have it as cos A cos B plus sine A sine B. Okay? Now for the tan A plus B, we have it as tan A plus tan B all over 1 plus tan A tan B. So this will be tan A plus tan B will be divided by 1 minus tan A tan B. So for tan A minus tan B minus B will give us tan A minus tan B all over 1 plus tan A tan B. All right. Now, when we look at our double angle formulas, we have it as sine 2A will give us 2 sine A cos A, and cos 2A will give us cos squared A minus sine squared A. And tan 2A will give us 2 tan A divided by 1 minus tan squared A. Now, trigonometry is used to solve for unknown sides and angles of a right angles and non-right triangles. Now, the laws majorly used, we have our Pythagoras rule, we have our Pythagoras rule, which says that our hypotenuse squared in the right angle triangle, this is for right angle triangle, that in a right angle triangle, the square of the hypotenuse equals to the sum of your other two sides, which is the opposite square and adjacent square. All right, now that's the first rule. Now the second one we have is a sine rule. Sine rule is used for finding sides of a triangle when we have two angles and a side. So we have B over sine B and C over sine C. Okay, now then we have our cosine rule. Okay, this we have as A squared equals B squared plus C squared minus 2BC cos A, or B squared equals A squared plus C squared minus 2AC cos B, or C squared equals A squared plus B squared minus 2AB cos C. Now, depending on which side you're looking for, you can also find our cos A, okay, cos B, and cos C using this. For example, if we want to find our cos A from here, we have A squared equals B squared plus C squared minus 2BC cos A. So we are going to make our cos A as subject of formula. So in order to do that, we would have it as B squared plus C squared minus A squared equals 2BC cos A. So therefore, cos A equals B squared plus C squared minus A squared all over 2BC. So that means cos B would be A squared plus C squared minus B squared all over 2AC, and cos C would be A squared plus B squared minus C squared all over 2AB. So this is for finding the sides and this is for finding the angles. With this, we've come to the end of our lectures on trigonometry. We'll be looking at some practical questions on trigonometry. So ensure you stick by to follow us and ensure you subscribe.
Hi, I'm sure you enjoyed the content you just watched. To see more episodes as that, preparing you for your oncoming exams, smash the subscribe button on this channel right now and visit the playlist that we've made for you, covering over 50 types of different exams, including JAMB, WAEC, Cacao, NET, IELT, and the likes like that. Also, in every video you watch, we have the link to our apps where you can download on Google Play Store and Apple Play Store and practice hundreds of past questions for free.